Hi everyone, my name is Liu Shuisheng and now I'm going to give a brief introduction about our drug.
Paclitaxel is an anti-cancer drug derived from yew tree. This is paclitaxel in injectable form. Paclitaxel is clinically used to treat cancer and might cause adverse drug reaction depending on individual. The lethal dose is 32,530 microgram per kg. Overdose cases in pediatric patients may lead to acute ethanol toxicity. Paclitaxel interferes with the normal growth of microtubule. Paclitaxel binds to the beta subunit of tubulin and hyperstabilize the microtubule structure.
Hello, I am Hilmi. For my part, I will explain about the drug nomenclature. ATC coding of paclitaxel. There are 5 levels of drug coding according to the ATC classification system. For the first level is L, which is the antineoplastic and immunomodulating agent. For the second level is LO1, which is the antineoplastic agent. For the third level is LO1C, which is the plant alkaloids and other natural products. For the fourth level is LO1CD, which is the toxins. And the fifth level is LO1CDO1, which determines the molecule's paclitaxel. There are several functional groups that present in this molecule, such as aromatic ring, alcohol group, amino group, ester, ketone, and ether.
Hi, my name is Muhammad Zul Irfan bin Zulkifli. I will show the 2D and 3D structures of paclitaxel and its ligand binding interaction. This is the 2D structure of paclitaxel. There are 14 oxygen atoms in the structure of paclitaxel. And there is one nitrogen atom, and it is labeled blue. The rest are carbon atoms. There are 46 of the carbon atoms. This is the 3D structure of paclitaxel. And this is also the 3D structure of paclitaxel. This picture shows taxol binding interaction with mammalian B tubulin. The location of amino acids stated are shown in dark gray. The amino acids involved denotes the binding site of the ligand
I am Nur
to the
Amira
mammalian
and I'm going to
tubulin.
explain the physicochemical
Thank you.
properties of paclitaxel. The molecular formula of paclitaxel is C47H51NO14. Based on the calculation, the molecular weight is 853.9061 gram per mole. The HBA and HBD of paclitaxel. Hydrogen atom attached to electronegative atom is HBD, and electronegative atom such as FO or N is HBA. Based on the structure, the atom in the green box is the HBA, while in the red box is the HBD. After calculated, the HBA is 15 and HBD is 4. Now it's for lipophilicity part. Lipophilicity included all the 4 points: log P, molar refractivity, pKa, and percent ionization at pH 7.4. The log P is 3.96, molar refractivity is 219.26 plus minus 0.4 cm3, pKa at strongest acidic 10.36, and pKa at strongest basic is -1. By using the pKa values, the percent ionization at pH 7.4 is calculated. At strongest acidic is 0.1, at strongest basic is 99.9. Therefore, it is most soluble in basic form and insoluble in acidic form. Now is to predict the solubility using Lemke's formula. The total C of paclitaxel is 47, but the solubilizing potential of functional group is only 27. Therefore, paclitaxel is insoluble in water. We have arrived at the fulfillment of Lipinski's rule. It shows that only HBD and log P fulfill Lipinski's rule, but the molecular weight and HbA is not fulfill the Lipinski's rule. It shouldn't be more than one violation of the 4 rules to fulfill Lipinski's rule. Thus, paclitaxel is not orally active. Thank you.
Optimizations. I am Chaying. Our modifications on the drugs is based on lipophilicity. We modified drug A by change the group at carbon 2, 4, and 7. As you can see, these are the characteristics of the new modified drug A. The reasoning on the modified drug A is at carbon 2, we add a polar OH group to increase the polarity, while at the carbon 7s, we change to ester group. This is a kind of product to improve the aqueous solubility. Next, we change the group at the carbon 4. This is because there is no interactions with the protein. So we believe that our drug A is more hydrophilic than original paclitaxel and have reached an optimal lipophilicity. Therefore, it can penetrate the biological membrane and more soluble in blood.
The structure of paclitaxel and different types of conformation. This is the structure obtained of paclitaxel in 2-dimensional by using ChemSketch. This diagram shows the structure of paclitaxel before minimization energy. After minimization, it will become something like this.
Hi, I'm Hamiza. This is the graph of the minimization energy versus number of cycles, which is 500 cycles. For our order, according to Hyperchem, the minimization energy is 811,659.8385 kilocalorie per mole. These are several other conformations that can be made out of the paclitaxel structure. Ball and stick. Stick. Space volume. And CPK.
I am Nur Shahira. Which functional group is changed? This. Molar reactivity of this drug is lower than paclitaxel, thus making this new drug less steric.
Hi, I'm Diana. I'm going to talk about fulfillment Lipinski rule for modified drug B. Number of hydrogen bond donor group is 4, number of hydrogen bond acceptor group is 17, molecular weight is 849.9, and log P is 7.19. Reasoning on the modified drug B. Paclitaxel has bulky, complex, fused taxane ring and 3 benzene rings which contribute to its high steric effect. Higher molar refractivity infers a lower steric effect and vice versa. Drug B has lower molar refractivity compared to paclitaxel as its value is lower. The modification of drug B is made by removing bulky phenyl group attached to the amide group and replace it with T-butyl alkoxy group. This causes the new structure to be less bulky and able to pass cell membrane more easily. Thus, the biological activity of this drug will increase as the therapeutic concentration of drug in the target cell is easier to be achieved.
Hello everyone, my name is Vigneshwari Ramasamy. I'm going to discuss about the drug C modification. The modification made is the ring contraction at ring A from 6-membered to 5-membered. After calculating, these are the results obtained based on the modification. It fulfilled one out of the 4 rules. The modification is the removal of one carbon atom from ring A, which will decrease the ring size and bulkiness of the group. As you can see, it also effective in tubulin accumulation and also decreases in cytotoxic effect against lymphoma cells. So it's like killing two birds with one stone. It also does lessen the damage to white blood cells in our body, which will decrease the side effect of neutropenia. So this modification mainly targets the pharmacodynamics aspect in our body, which is toxicity and its side effect. Thank you very much.